Okay, in this example, we're going to look at how to solve this polynomial equation where we can recognize a sum of two perfect cubes. X cubed is obviously a perfect cube. It's x to the third power. And then plus 64. 64 is also a perfect cube. It's 4 to the third power. So I'm going to go ahead and rewrite that for a second. X cubed plus 64 is 4 to the third power. So I'll go ahead and show you that. And then recall how to factor a sum of two perfect cubes from before. This is what factors into a binomial times a trinomial. So we've got to make sure we recognize and remember that structure. And then we'll just take one factor of this first term, just x to the first, put it there, and the other two factors of that first term will go first in the trinomial. And then we'll do the same thing with the last term to fill in the last places. We'll take the last term here, one factor of that last term, so 4 to the first right there, and the other two factors, 4 squared, which would be 16, would go at the end here. And then this middle term of this trinomial is just the product of these two terms in the binomial. So x times 4 would just be 4x. I didn't fill in any signs yet. We had a little acronym SOAP, stood for same, opposite, always positive, to try to fill in the signs. This first sign should be the same as I was seeing in the original problem, so that one should be plus. The next one should be the opposite of that, which would be minus, and the last one will be always positive. At this point, I've taken care of the factoring. I've broken down this sum of two perfect cubes into a linear binomial times a quadratic trinomial. The linear binomial is pretty easy to go ahead and set equal to 0 and solve. So I say x plus 4 equals 0, and then I can solve that in one single step by just subtracting 4 on both sides, and I'll have x equals negative 4 as one of the solutions to this polynomial equation. Now, this quadratic trinomial that I'm left with, x squared minus 4x plus 16, is not factorable. I'm not going to be able to find numbers that multiply to positive 16 that add up to negative 4, so I need to revert back to some other method of solving this. I might recommend the quadratic formula, where a is 1, b is negative 4, and c is positive 16. So I'm going to go ahead and do that to finish this off. I'm going to go ahead and remember down here that we got x equals negative 4 as one of our solutions. Go ahead and give myself a little bit more room to work to solve the rest of this. Find my other solutions. So I need to continue solving x squared minus 4x plus 16 equals 0 using the quadratic formula. So I will go ahead and do that. I will have x equals the opposite of b. In this case, if b is negative 4, the opposite of that would be positive 4, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Again, at this point, I would recommend going ahead and computing your discriminant. So we have 4 plus or minus the square root of, let's see, negative 4 squared is 16 right there, and then minus 4 times 1 times 16, so that's minus 64 right there. So 16 minus 64, that's a negative 48, all divided by 2 times 1 is 2. So my discriminant there being negative 48 implies that I'm going to have two imaginary solutions out of this, so I'll just go ahead and continue to work those out, simplifying this radical. Again, I have another video on how to simplify square roots using the imaginary unit I, if you need to reference that. So finishing this off, I have 4 plus or minus. I'm going to split off the negative 1, and then the 48 can break down as 16 times 3, all like so. So I have 4 plus or minus. The square root of 16 is 4. The square root of negative 1 is I, so that becomes 4i square root of 3, all divided by 2. And then last but not least, do a little bit of simplification here with the fraction. The 4, and the 2 can all be divided by 2. So this will become 2 plus or minus 2i square root of 3. I would need to write over 1 with that. So I have my other two solutions to that right there. I have negative 4, and I have 2 plus or minus 2i square root of 3 as my other two solutions for this equation. And now I'll have you take a look at this one on your own. This one is a difference of two perfect cubes, so be careful when you're factoring that you get your signs correct. They'll be a little bit different than the last one, since this sign is a negative instead of a positive. But again, reference the sum and difference of cubes factoring videos that I have if you need any help with that. And go ahead and check your work to this on the next slide to see how you did.